The National Electrical Code, or NEC, does not specifically address bonding metal gas lines to lightning protection systems. However, this practice may be advisable for several reasons. Firstly, it ensures electrical continuity. A bond between the gas line and the lightning protection system provides a low resistance path for lightning current to ground, reducing the risk of electrical shock or damage to equipment during a lightning strike. Secondly, bonding minimizes electromagnetic interference, also known as EMI. Lightning strikes generate strong electromagnetic fields that can disrupt electrical equipment. Bonding the gas line to the lightning protection system helps shield sensitive electronics from EMI. Thirdly, gas lines can accumulate static charge, posing an ignition hazard. Bonding the gas line to the lightning protection system allows static charge to safely dissipate into the ground, preventing potential ignition. While the NEC doesn't mandate this specific bonding, it does provide general guidance on electrical bonding. Section 250.104 C addresses electrical bonding requirements where conductors or equipment are connected to different grounds or separated by non-conducting surfaces. Additionally, Section 250.110 states that metal raceways, cables, and other equipment must be bonded where they enter a building or structure. Because of the above considerations, bonding metal gas lines to nearby ground wires from a lightning protection system is recommended for enhanced safety. This bonding provides a low resistance path to ground, mitigating electrical shock and damage during lightning strikes. It also minimizes electromagnetic interference, safeguarding sensitive electronics, and prevents the buildup of static charge, reducing the risk of ignition. It is important to consult with a qualified electrician or lightning protection expert to ensure that the bonding is properly installed and compliant with all local codes and regulations. This ensures that the system is safe and effective. Incorrectly installed systems can be ineffective and may even increase safety risks. They can help you assess the specific needs of your building and design a bonding system that meets those needs. They can also ensure that the system is installed in accordance with all applicable codes and regulations. Bonding can have other implications as well. For example, consider the potential impact of corrosion. Dissimilar metals in contact with each other in the presence of an electrolyte, such as moisture, can lead to galvanic corrosion. Ensure that the bonding materials are compatible to prevent this. Different types of metal, when connected, can create a battery-like effect in the presence of moisture and corrode and fail over time. Proper selection of bonding materials is crucial. Think about future maintenance. Ensure that the bonding connections are accessible for inspection and maintenance. Regular inspections can help identify and address any issues before they become major problems. Proper maintenance can help ensure that the bonding system continues to function effectively over time. Keep records of all inspections, maintenance, and repairs performed on the bonding system. These records can be helpful for tracking the performance of the system and identifying any potential problems. Also, consider local regulations. Confirm whether local jurisdictions have specific requirements beyond the NEC regarding bonding gas lines to lightning protection systems. Staying informed about local regulations helps ensure compliance. Local regulations can vary widely, so it is essential to check with the relevant authorities. Some jurisdictions may have stricter requirements than others. Keep in mind that there could be potential impact on gas flow. Ensure that bonding does not impede the flow of gas through the pipeline. Any bonding method should not compromise the integrity or performance of the gas line. This could lead to safety hazards and operational problems. It is also a good idea to assess risk. Conduct a comprehensive risk assessment to determine the necessity and scope of bonding. Consider factors like building height, location, and occupancy when evaluating the risk. A risk assessment can help determine the appropriate level of protection. Consider the potential for mechanical damage. Protect bonding connections from physical damage or tampering. Use appropriate enclosures or guards to prevent accidental disconnection or damage. Mechanical damage can compromise the effectiveness of the bonding system. Also, make sure to have proper documentation. Maintain detailed records of the bonding system, including materials used, installation methods, and inspection results. This documentation can be valuable for future maintenance and troubleshooting. Good documentation can also be helpful in the event of an insurance claim. Another consideration is training. Train personnel on the importance of bonding and how to identify potential problems. This helps ensure that the bonding system is properly maintained and that any issues are promptly addressed. Regular training can help prevent accidents and ensure the safety of building occupants. Think about future upgrades. Plan for future upgrades or modifications to the gas line or lightning protection system. Ensure that the bonding system can be easily adapted to accommodate these changes. This helps maintain the effectiveness of the bonding system over time. Also, remember to reevaluate periodically. Reevaluate the bonding system periodically to ensure it continues to meet the needs of the building. Changes in occupancy, equipment, or environmental conditions may necessitate adjustments to the bonding system. Periodic reevaluation can help identify any potential problems. When bonding, consider the use of exothermic welding. Exothermic welding provides a permanent, low-resistance connection for bonding conductors. This method is often preferred for grounding and bonding applications because it creates a molecular bond between the conductors. Exothermic welding is particularly useful in harsh environments where corrosion is a concern. It is also useful for bonding to similar metals as it eliminates the risk of galvanic corrosion. When doing this work, follow a grounding electrode system. Ensure the lightning protection system and gas line are connected to a common grounding electrode system. This helps equalize potential differences and minimize the risk of electrical shock. A well-designed grounding electrode system is essential for effective lightning protection. It also helps to minimize the risk of electrical shock. Also consider surge protection. Incorporate surge protection devices, or SPDs, at the service entrance and other critical locations to protect against transient voltage surges. These surges can damage sensitive electronics. Surge protection devices can help prevent damage to electrical equipment. They can also help improve the reliability of the electrical system. Also, think about the type of clamps and connectors. Use appropriate clamps and connectors that are specifically designed for grounding and bonding applications. These connectors should be corrosion resistant and suitable for the environment in which they will be used. Make sure the connectors are properly torqued to ensure a secure connection. Loose connections can create a fire hazard. Consider the location of the grounding electrode. The grounding electrode should be located as close as possible to the gas line and lightning protection system. This minimizes the length of the grounding conductor and reduces impedance. The grounding electrode should be installed in accordance with all applicable codes and regulations. Also, when doing this work, consider inspection frequency. Establish a regular inspection schedule for the bonding system. This helps identify and address any potential problems before they become major issues. Regular inspections can help ensure that the bonding system continues to function effectively over time. It is also important to keep records of all inspections, maintenance, and repairs performed on the bonding system. Consider the environmental conditions. The environmental conditions in which the bonding system is installed can affect its performance. In corrosive environments, it is important to use corrosion-resistant materials. In wet environments, it is important to ensure that the bonding connections are properly sealed. Think about the use of a grounding busbar. A grounding busbar provides a convenient point for connecting multiple grounding conductors. This can help simplify the grounding system and improve its performance. The grounding busbar should be sized appropriately for the number of conductors that will be connected to it. You should also think about separation of systems. Maintain adequate separation between the lightning protection system and other metal objects such as plumbing and HVAC systems. This helps prevent flashover and reduces the risk of damage to other systems. Adequate separation can also help minimize the risk of electrical shock. Also remember to verify continuity. Verify the continuity of the bonding system using a multimeter or other testing equipment. This helps ensure that there is a low resistance path to ground. Continuity testing should be performed after the bonding system is installed and periodically thereafter, and make sure to torque connections properly. Tighten all bonding connections to the manufacturer's specified torque. Over-tightening can damage the connectors, while under-tightening can result in a loose connection. Proper torque is essential for a secure and reliable connection. Consider a third-party review. Have a qualified third party review the bonding system design and installation. This helps ensure that the system meets all applicable codes and regulations and that it is properly installed. A third party review can also help identify any potential problems. Proper design, installation, and maintenance are critical to the effectiveness of these systems. Ignoring these systems can create a safety hazard.